Hello my beloved friends, you are highly welcome to this class, and in this class we'll be considering this topic, rational inequality. In our previous classes we studied the study of inequality, and today we want to study another aspect of inequality. We want to look at rational inequality. So rational inequality has to do with inequality involving fractions. How do you solve problems on inequality involving fractions? This is what we are going to be studying in this class. So we are going to be doing that with the aid of examples, and we have one example already on the board we are going to consider. So let's do that together. Looking at this example, they asked us to solve this inequality x squared minus 1 divided by x squared minus 3x plus 2 less than or equal to what? 0. So this is the rational inequality we have, because this quantity here is a fraction and we have inequality here. So to do that, we are going to quickly consider what we have here. X squared minus 1 divided by x squared minus 3x plus 2, then we have less than or equal to what? 0. What we have up here is a quadratic expression which we can factorize. So this simply implies x squared minus 1. We use difference of two squares to factorize this. So using difference of two squares, this will give us x plus 1 multiplying x minus 1, because we can write 1 as 1 squared, right? We now use difference of two squares. Okay, so we have factorized the numerator, then you factorize the denominator, right? So you are going to use the method of factorizing quadratic expression, and if you do that, you are going to have that x squared minus 3x plus 2 will be equal to x minus 2 multiplying x minus 1. So this is the factorization of this. Then we have less than or equal to what? 0. Clearly, x minus 1, which is at the numerator, will cancel x minus 1 at the denominator, so that what we have left is x plus 1 at the numerator divided by x minus 2 at the denominator, then all less than or equal to what? 0. So to solve this, you are going to draw your number line, and here is negative infinity and here is positive infinity. At the middle you are going to have what? 0. So we know that here you are going to have 1, you are going to have 2, you are going to have 3. Here we are going to have minus 1, minus 2, minus 3. So what you are going to do is you are going to set the numerator equal to 0. If you set numerator equal to 0, you are going to have x plus 1 equal to 0, which implies x is equal to minus 1. So we have see minus 1 here. We locate minus 1, we locate minus 1. Okay, so I located minus 1 where minus 1 is. Then you are going to set the denominator equal to 0. So x minus 2, you set it equal to 0. If you move minus 2 to the other side, how that x is equal to 2. See 2 here, 2 is here. So we have located the 2 points that will make the numerator equal to 0, and that will make the denominator equal to 0. Once you have done that, the next thing is to substitute numbers that are bigger than these points. Remember, we considered 2, we considered what? Minus 1, right? Okay, if you pick number bigger than 2, pick any number bigger than 2 and check whether this side will satisfy this inequality. So if you pick number bigger than 2, let me say 3, pick 3 for instance and put here. You are going to have 3 plus 1 is 4, and you are going to do 3 minus 2 is what? 1. But 4 divided by 1, we are going to get what? 4. But 4 is not less than 0. So these numbers bigger than 2 cannot give you the correct answer. All numbers bigger than 2 cannot give you the correct answer. Of course, 2 itself is a wrong option, because if you put 2 here, you are going to have 2 minus 2, which will give you what? 0, making the denominator to be what? 0. And if the denominator becomes 0, you are going to get what? Infinity. 2 is not also a correct option, so we cancel 2. Then we are going to check numbers between -1 we are considering and 2. Pick any number in between here. You can pick 0, you can pick 1, anyone. So let's just pick 1 for instance. If I pick 1, put 1 here, I'm going to have 1 plus 1 is 2. Then put 1 here, 1 minus 2 is -1. 2 divided by -1 will give you -2. Clearly, -2 is less than what? 0. So numbers between -1 and 2, we mark it good. We mark them good, right? Okay. What of, let's check -1, right? -1, if you put that's this point -1, definitely -1 will make the numerator to be what? 0. And if the numerator becomes 0, this whole thing becomes what? 0. And 0 is equal to 0, because our inequality is saying less than or equal to 0. So if you get 0, 0 is equal to 0. So the point 1 itself is, we are going to tick it good. So if you look at numbers smaller than -1, pick any number smaller than -1. You can pick -2 for instance. Pick -2. If you put S for -2 here, -2 plus 1, -2 plus 1 will give you -1, divided by -2 minus 2 will give you what? -4. And -1 divided by -4 will give you 1/4, because minus will cancel minus. But 1/4, which is 0.25, is bigger than what? 0, right? But we are looking for numbers smaller than 0 or equal to 0. So this number is bigger than 0, which make all the numbers bigger than this point, all the numbers bigger than -1, we cancel them. So what is the answer now? The solution is, so what we got is numbers starting from -1. So because it's starting from -1, use close bracket as -1 comma to what? 2. But 2 itself is not among, because 2 will make the denominator to be 0, and it will make this thing to be infinity. Once the denominator becomes 0, the whole thing will go to infinity. So because 2 itself is not among, you are going to use open brackets at the side of 2. So this gives you what? The solution to this very rational inequality. So see you in our upcoming class as we explore more examples on this topic. Bye.